Okay, so good afternoon and welcome to the second in the 2016 London Digital Classicist Seminars. We're extremely happy this week to welcome our colleague and one of the co-organizers of the Digital Classicist community, in fact, the convener of the Berlin seminar, Dr. Matteo Romanello from the Deutsche Archäologische Institut in Berlin and the EDFL in Lausanne, who is going to talk to us today about of people, places and references, extracting information from classics publications, which I will let him explain in a moment what all that means. Let me just switch screens to your slides. Yes, okay, great. I'll pass that over to Matteo now. Thank you, Matteo.
Well, thank you, Gabby, for the introduction. Thank you all of you for coming. It's a pleasure. It's a pleasure to be here and to see many colleagues, friends, and okay. So what I'm going to talk about today, it's well, I will start first by putting name identity recognition into context, explaining a bit what it is and why it's important for extracting information from text automatically. I will then go through some examples of name identity recognition specifically in classics, focusing on first people and places. And then I will move on to what has been, what was my PhD research, which is another application of NER, but still in classics, but to references, to extract automatically references to ancient texts. Well, let's start first of all a bit with the origin of information extraction. All the research started in the 1980s, was financed by the US Navy and by the Defense Advanced Research Project Agency, the DARPA, in the US. And they were financing the first attempt to try to extract information automatically concerning from military texts. So the focus was particularly on military information. Information extraction focuses on elements of interest that are extracted from text. And elements of interest, it's so general that one understands already that information extraction is very domain specific. Depends on the domain in which one works, and also depends on the application that one is building. But the initial focus of research on information extraction was on three types of elements of interest: events, entities, and relations between entities mentioned in the text. Well, let's start with a bit of definition about what is a named entity, for example. Well, a named entity, it's an element in a text that designates a referent. And a referent in the linguistic theory is the person or the thing to which a linguistic expression refers to. Can be a string in a text, can be any other set of symbols. There are different types of named entities. What is generally considered a person, organization, and location. This is what you'll find generally in many research papers, many conferences. The focus is on these three types of entities. So mentions of people, mentions of organizations like Google or Microsoft in a text, and location, like geographical location, mentions of place names. In addition to this, sometimes people also focus on temporal expressions, like events, dates, and similar expressions, and amounts, currencies, percentages, and other numerical expressions contained in text. But as I said before, it's very domain-specific and application-specific, and this means that people have adapted these general types of entities to other domains. So for example, in biomedicine, people try to extract from text mentions of genes, proteins, DNA, RNA. If one looks at researching legal texts, then people try to extract mentions of judges, attorneys, jurisdictions, and courts. And then, of course, when we look at classical texts, we have plenty of mentions of other types of entities. There are mentions of people, ancient and modern, mentions of places, also ancient and modern, but also references where the referent is a text or a document, so references to papyri, references to inscriptions, references to canonical texts, which will be the focus of the second part of the presentation. Well, let's give an example of the not only what they look like, but also what it means extracting them from text. So this is a small text extracted from the Wikipedia article about Aaron Swartz, who, like probably many of you know, was an internet activist. So there is a text that says at some point in the Wikipedia page, 2 days after the prosecution rejected a counteroffer by Swartz, he was found dead in his Brooklyn, New York apartment where he had hanged himself. So the first two things that are named entity mentions that we can extract from a text are the last name of Swartz, and then also the pronoun he, which refers again to Swartz. Even if he's not mentioned explicitly, linguistically it's an anaphora, which means one word is referring to something that has been already mentioned. And then, of course, also the mention of the place names where he was found dead, in this case, Brooklyn, New York. The named entity session is usually broke down into smaller tasks that are executed to be able to extract these named entities. So the first one is to recognize that one word constitutes a named entity. In this case, as we have just seen, Swartz and Brooklyn, New York. Then there is the step of classifying. So this is an entity, needs to be classified according to one of the types that has been predetermined as pre-specified according to the domain and the application. So in this case, the classification says Swartz is a person and New York is a location. Then another step is the relation extraction, which consists of detecting relations existing between named entities that are mentioned in the text. In this case, one could, for example, formalize a relation called was found dead in, that has two arguments, two named entities that form this relation, where one is the person that is found dead and the other is the place where he or she is found dead. And the final step is to disambiguate the named entity, which is called named entity disambiguation or linking. We said already that Swartz and he refer to the same person, but we also want to identify a unique identifier, to assign a unique identifier to Swartz to distinguish that reference from other possible reference. So in this case, Swartz doesn't refer to one of the three actors mentioned in Wikipedia, but refers to the activist. So the disambiguation consists of finding the right identifier to be assigned to that specific named entity mention. Similarly, for places, one wants to assign an identifier, in this case, the URI taken from geonames, but also connected to that coordinates of the place on a map. But we'll go back to that later. So there are essentially two types of methods that one can use to automate the extraction of these elements from text. The first one is rule-based, which consists of defining manually by hand rules according to which a sequence of words is classified as being an identity. The type of information that is usually exploited by this kind of approach is linguistic information, like morphosyntactic information about the word itself, but also lexical information. Like, for example, if the word Google is found in a dictionary with names of organizations, for example. And for this purpose, I use dictionaries and gazetteers, particularly for place names. So for example, there can be rules like if there is a first name, so a word that matches in a list of first names, followed by an uppercase word, then that string is going to be a person. These are examples of rules that one can define. Similarly, an unknown word followed by .ing. So unknown word means a word that is not found in any well, a word for which I think morphological information is not says it's not able to assign the right information. Followed by ing, then it's going to be an organization, a proper name, ampersand, and another name. Then it's very likely to be an organization, or a location preceded or followed by an action verb. It's probably going to be a geopolitical location. And then the other approach is statistical. So it's not based on rules defined by the user, but it's based on the data. So the first requirement is annotated data to be able to train a model to derive these statistics. And statistical methods work by estimating the probability of a category for a given word or sequence of words. So it's all about calculating, computing the probability given a certain set of information. Requires annotated data. There are probabilistic models that are based on words and text. So the probability of a tag to be assigned to a given word, given that word itself. And then also probabilistic models based on other features, where other features can be many different features that one can extract from a word. Like, for example, is this word contained in a dictionary or a list? How is the capitalization of the word? What is the part of speech information of the word? So is it a noun, a verb, an adverb? And one can define the set of features quite freely. One part that is quite key for comparing different approaches to the identity recognition is the evaluation. And I will say something about this because there is going to be one small part in the second part about evaluation, but also because if you come across in research about named identity recognition, you will find very often tables with results and evaluation, and the three words precision, recall, and F-score will very often appear. So it's just to say what they mean. So essentially, there are 4 types of errors that one can identify when evaluating this task. So true positives, that section of the graph, are words that the system identifies as being an identity, and in fact are an identity. So they are not an error, but a positive match. But there are also false positives, which are words that the system believes are named entities, but in fact they are not named entities. So true positives and false positives. And based on these 2 types of errors, it's computed the precision. So the precision of a system based on the correct matches and the matches that shouldn't be there, but they are. But there is also another measure, which is the recall, which is also taking into account the false negatives. And the false negatives are named entities that should have been captured by the system, but they are not. So in other words, the precision is capturing how well in the set of identified entities the system performs, whereas the recall, it's also looking at what has been missed by the system. And these 2 types of measures combined together constitute the so-called F-score, which is basically a mean of these 2 values. And there can be different variants of this F-score based to the weight that one assigns to each of these 2. So it's possible to, usually you will find the F1 score, which means the 2 measures have the same weight, but you can also find other types of F-score, but most commonly the F1 score. Okay, so given what I've just said, I think you have realized that in classes we are used, even if maybe we don't call them named entities, we are used to named entities. And if one looks at a resource like the the Real Encyclopedia, the Pauli Visova, it's basically a list of named entities of different types. And well, I actually discovered on Wikisource that a good amount of the Pauli Visova is accessible and also searchable. So one can, for example, search for Aristophanes, and what you will find are 12 or maybe even more matches. And this is a problem of disambiguation. So the encyclopedia is doing for us identification of named entities and also disambiguation. But it's basically the same idea, same mechanism. Just with the difference that when one does it, automatically tries to automate this process of disambiguation. But the information that is in the Real Encyclopedia could as well be used in a system to create these links from named entities to what they refer to. Another example of named entities, but extracted manually and not automatically, is the LS-PRONT project, which was developed by a project that involved the German Archaeological Institute, where I'm working, and the Perseus project, and was funded by the NEH, by a grant by the NEH DFG. And I also wanted to, if you're interested in the project, just appeared a nice article by a colleague of mine that describes specifically the linguistic annotation he has done in this specific project. He also mentions the named entities, but he focuses mostly on the syntactic trees of the text that he has been building, essentially. And this project focused specific, so was a very, the focus was very narrow because focused on one section of the first book of the histories by Thucydides, the so-called Pentecontetia. But essentially there was someone going through the text and annotating the parts of text that she believed were named entities. There are mentions of people, mentions of places, and in the interface, in the ready view of the Hellespont, for example, when there are entities, there are place names mentioned, then it's possible to also to see them on the map. And in another view, it's also possible to see basically the disambiguation. So because for each entity, she has assigned the link, for example, to the object, like the walls of Athens are mentioned, and then she assigned the identifier of the record in the Arachne, which is the object database of the German Archaeological Institute. So it's something that one can try to automate it, but there can be also reasons for doing it manually to understand how to model the text. Another example in this case, of a tool that one can use to extract named entities from Latin and Greek texts is the Classical Language Toolkit, which is a library written in Python and open source that tries to replicate essentially another package, which is the Natural Language Toolkit, which is more for English and modern languages, and CLTK tries to do the same, but providing resources for ancient languages. And one of the modules that there are in this library, it's for named entity recognition from Latin and Greek texts. And for now, it's a very simple system and method. They are using essentially the rule-based method, so trying to match words against two lists of names, lists of proper names in Greek and Latin, which I think they're coming from the Perseus project. But if one wants to annotate named entities in primary sources, written in Greek and Latin, this could be, for example, a starting point. One thing is, right now they have only one type of entity, so everything is tagged as an entity, no matter if it's a place or a person or something else. But they are at the, well, they said they're still developing it, so it's at the beginning. For place references, sometimes another terminology is used, where the recognition and classification, it's also named geoparsing, and the task of disambiguation and linking, it's called georesolution. But they are essentially talking about the same thing, but focusing specifically on place names. And on this specific area, there have been a few projects that have worked on the automatic extraction of place references. One was the Google Ancient Places, that has tried to extract them from text in Google Books. They focus on a subset of Google Books. They've used the gazetteer from Clearis to match place names that were found. So there is ambiguation. And for the parsing and the resolution, they use the Edinburgh GeoParser. So a very useful work they've done was to take a tool like the Edinburgh GeoParser, which is very general. It's not specialized on ancient place names, but it's working mostly on modern place names, and finding what are the resources that need to be provided to adapt this tool to mentions of ancient place names. And for example, they had to tweak slightly the Clearis gazetteer, and then they've released the data as open source, so other projects can build on this. Well, another project that you very probably know, it's Pelagius and Recogito. Well, Recogito is a web application built for Pelagius for the annotation of references in the documents. So a first pass to extract the entities, it's done automatically using not the Edinburgh GeoParser, but the named entity tagger developed by Stanford. But they're also using the Clearis gazetteer and of course the Pelagius gazetteer to match the entities. But then there is a very nice interface, which is Recogito, which allows the user to check each entity and basically correct the data. So correct if it's not a real mention, and also check the resolution. Another project that I wanted to mention is the Coptic Scriptorium. And I wasn't aware that they were doing also named entity recognition, and I discovered it a few days ago. So they are doing it on Coptic text, which I'm not able to read, so I'm not gonna try to read them. But what is peculiar of this project is that they start from a very rich linguistic annotation of the text, and based on that, they do the named entity recognition. And I say peculiar because many times linguistic features are not taken into account by the named entity methods because they are very expensive in terms of time to be produced. But they're starting from a very richly annotated corpus of Coptic text, and then doing the anaphora resolution and also named entity recognition of these texts. So this is the output, for example. They have a live demo in the slides. In the bottom there is a link if you want to check it out. And basically the colors identify all named entity mentions to the same person or to the same entities. And they have different types of entities. There are animals, persons, locations, abstract concepts. I think it's, and the last project I wanted to mention is Proteus, which tried to do all what I just described, but on a very large scale. So they've used all the books in the Internet Archive, and they tried to do extraction of location, mentions of organizations and people from millions of books in the Internet Archive. And it's a very, very interesting project for the scale in particular, because they started from the images available, and in the pipeline they have OCR, they detect quotations of one book in other books contained in the Internet Archive, and the named entities, it's one part of this information extraction system. So there are also challenges for doing this type of work in our domain. And the main challenge is that tools that are not built especially for classics need to be adapted to our domain. So, for example, we need to adjust the types of entities and identify entities that are of interest for classicists. Like in my case, for example, mentions of ancient authors and ancient texts and canonical references. Another problem is also the language adaptation, because in many cases are tools and resources that work well for English, and as soon as someone tries to use them for other languages, then they're not working anymore because they lack the resources that make it possible. And this is also the reason why the CLTK project started to kind of solve this problem. Another problem is the lack of annotated datasets that, as I said, are very expensive to produce. In some cases, there is a lack of language resources, so a lack of gazetteers, lists and dictionaries that one can use. I think in Classics we are quite lucky right now because there are resources like Pelagios for places, but also Snapdragon for names of peoples. And of course, there is Perseus and the Classical World knowledge base for text. So there is an increasing number of knowledge bases that can be used to get knowledge and information to automate this process. And then coming now to the second part, which is more describing the name entity recognition system I built, especially for extracting canonical references. I usually have this slide for people that have no idea what canonical references are, but I don't think it's the case with this audience, so I will keep it very briefly. They are references to canonical texts, so primary sources that we have in classics, and they are characterized by the fact that they don't refer to the pagination, for example, when they cite a passage of a text, but they refer to an abstract structure, like the logical structure of a text. But they are not the only kind of references we have. There are references to inscriptions, references to papyri, references to manuscripts, also references to coins, fragments. So I focused on one specific type of references, but there are many other that will need to be captured. And the data I work with, well, one of the two corpora are the texts from the Nane Philologique, and I think also in this case I don't need to say what it is. It's the starting point basically for each research in classics, the place where one goes to do the literature review to see what has been published on a certain subject, and it's not surprisingly full with canonical references. But they are very short abstracts containing the references, for example, of the main passages discussed by publication. And they look a bit like this. So it's the abstract of reviewing one specific publication, and they tend to be very short. And what is highlighted here are canonical references that are found in the text. So I've modeled the biggest part of the work was to model this problem following the more general paradigm of named entity recognition. So following these three steps of extraction, classification, relation, extraction, and disambiguation. So the very first steps is to extract the named entities from the text. And in this case, I have identified 4 types of entities that allowed me to formalize a reference. And they basically represent the components of a citation. And these components put together, then they form references. So the first entity, it's a mention of an ancient author. The second entity, it's a mention of an ancient work that is found in a text. Then there is one entity with a very ugly name, but that basically try to capture both. So it's a structured reference that can be either to an author or to a work. And this was needed because there are some tricky cases like the abbreviation for Thucydides, where what is found in the text is the abbreviation of the author, but what is meant actually is the histories of Thucydides. So the opus, so the so-called opus maximum of the author. So in that case, yes, it's true, it's a reference, it's an abbreviation to an author, but what it represents is actually what it stands for. It's a reference to a work. So to solve this problem, I created this hybrid entity. And then the last one is the scope, which identifies the scope of the reference. So which book, line, section, or paragraph that one is citing. So the first step is extracting all of this from the text. The second step is to extract the relations between them. And I have only one type of relation in my data. Basically, I'm representing a reference as a relation between two types of entities, where the first argument, so the first entity involved in the relation, it's always either an author or a work or a reference to an author or work. And the second entity has to always be the scope of the text cited, because otherwise it's not a reference. So these are the references that I'm starting from text. And some examples that are combinations of these three possible cases, basically. So someone can cite Ammianus with the name of the author, then the scope. Trabajos refers to the works by Hesiod. So in this case, mention of a work, and then the scope. And again, the example of Thucydides with the name of the author and the scope of the reference. And the final part is to disambiguate all of this, so to assign to each of these entities and relations a unique identifier. And the unique identifiers I'm using are the canonical text services URNs. How many people have never heard of CTS URNs before? So there are a type of identifiers that allows us to encode specifically an identifier for a specific passage of a text, and they are basically self-contained identifiers because they have in the same string all the information we need to identify that text. So they start with a prefix, then there is a namespace, then all this part, it's identifying the text that is being cited, which has an author, which in this case it's called test group, a work, so the Iliad or the Odyssey, and then an exemplar that can be one specific edition or translation of that work. And then, of course, there is the passage that expresses the scope of the reference. So, for example, for Homer, there is a CTS URN. With increasing granularity, one can identify the Iliad by Homer, and similarly, the first 10 lines of the first book with a very detailed and specific URN. The system that I've developed to extract these references from the Nanay Philologique works in this way. So the input, they are plain text, just strings of text without any kind of markup. There is a bit of text processing, where I identify automatically the language in which the text is written, because in the Nanay Philologique we have text in English, German, Spanish, French, and Italian. So one needs to identify automatically which language is written. The sentences are splitted, so each individual sentence is splitted, and then each sentence is split into tokens, so like words that constitute the sentence, and some part of speech information is extracted, like is it a noun or an adjective or a verb, and so on. And then there are the three steps that I just described, so extracting the components, then the relations between the components, and then disambiguation of entities and relations. And what one gets at the end is some annotated text that can be in many different formats. This is the evaluation of the system with the three measures of precision, recall, and F-score that I described before. I won't go into the details of the evaluations that I've done, but as you can see, there are two values about 73%, and one about 92%. So 92% was the assertion of the relations, which was done using a rule-based system, but it was already quite well. And in the other two tasks, so the recognition and the disambiguation, you can see, for example, the disambiguation has a very high recall, which is about 90%, but then a relatively low precision, which means the system doesn't miss many entities, but of those that captures, doesn't get many right. So slightly more than 50%. So this identifies an area where more work and more research is needed to improve those results. I wanted to show some error types of specifically of the disambiguation, because it's turned out to be one of the trickiest problem in this session of references. So one type of error are ambiguous abbreviations. So in this case, there is a reference to the Carmina by Horace, and the reference to the Carmina, so the abbreviation, it's found in another sentence. So they are in two separate sentences. There is first a mention of Horace, and then there is the reference to the text. And what the system does is first identifies Horace, and all is fine, and then comes to the abbreviation of the Carmina. And when that string is looked up in the knowledge base, there are probably 100 of works that are abbreviated as Carmina. So in this case, the problem is how to tell which work it is from another. So what one should do, which I haven't done yet in my system, is basically to look at the context, to look at the entities that are mentioned before and after an ambiguous abbreviation, and try to use that information to disambiguate. In this case, the entity that comes right before the abbreviation is Horace. So in that case, one can use that information to help the disambiguation. Another case, it's author mentions that are in itself ambiguous. So if you take Aristophanes, can be the comedian, can be the Alexandrian grammar scholar. How can the system know which one it is? Well, the human reader doesn't have much of a problem because it looks at the context. There are two words that trigger detention. So one is the interpretation of papyri, which is mentioned, and the other are the scholars from Alexandria that are also mentioned in the text. So the human reader takes these two contextual information, and it's able to know, well, it's definitely not the comedian. But in a system, in an automatic system, this can be quite problematic. Another error that I call implicit topicalization, it's basically when the context to disambiguate the reference, it's in the title of the publication reviewed, which happens very often with an philology, because if it's a publication about Homer's Iliad, there is no need to repeat. Well, one can avoid to repeat that that publication focuses on the Iliad by Homer, and just take that as the implicit topic of the text. So in that case, in this case, for example, the text says in the chapter 5 of a work by Lactance, but it's not said which work it is. So one has to go to the title, and then there is a mention of the work that defines the context for this reference. And then there are also references that are expressed in a way which is in itself ambiguous. So it's not a problem of the mentions being ambiguous, but it's the phrasing of the person who wrote this text that it's ambiguous. So in this case, the text just says the analysis of the pederastic poems, and then gives the number of the poems, but doesn't say which of the two works by Theocritus are, in this case, what is meant by pederastic poems. To finish, I had prepared, well, a very, very short demo. There is no chance it was going to work live, so I prepared a video, which is much safer. And it's a web service that does all this extraction and provides a user interface that allows the user to upload some text given to the system does all these extraction steps and then gives back some results. So in this case, I'm selecting a bunch of abstracts from the L'Année Philologique. They are loaded on this web service, and it's showing the progress. When everything is loaded, I specify what kind of output I want. So in this case, I have 4 different kinds of output. There is a JSON list of references, a CSV list of references, and also the annotation files that are generated. Then the system starts. In this case, I think there are about 150 texts. and takes about 5 minutes for the system to go through. I think I just, at some point I stopped it. But what I wanted to show here is that it's outputting what the system is doing. So for each test says, I'm starting to do the pre-processing, I'm starting to do the magnetic recognition, now it's done, now I'm moving on to something else. So the system is outputting some information about the status of the processing. Yeah, like in this case, it's starting with the pre-processing, and then it says all the operations that are being done on the test. And now I skip to the output part. These are all the results returned by the system. So for each text, all the extracted references, and also the CSV file and the JSON file that contains all the information. There is then a link here to download all these results as a zipped file. So instead of downloading one by one can download a zipped archive of all the output, which is what I'm doing here. Just taking that file and saving it to my computer. And then it needs to be uncompressed. So opens the archive and dumps all the content in a directory. Yeah. So here you see all the output that has been extracted before, dumped in a directory. And then it's possible to view both the annotations and also the other two outputs. So first, one can load the annotation in an annotation tool. In this case, I'm using RAT. So here I'm going to the folder where I've unzipped my archive. There are a bunch of texts. I can see, for example, how many entities have been extracted, how many relations for each text, and I can open one, and here is the same visualization that you've seen before. So the same entities and relations that are extracted from the text. But one can also search for example, one specific entity that was found by the system, in this case, Amianos. I think it's not finding anything. Then it's complaining that I'm not logged in. Well, here I searched for Ovid, and then it's showing the documents that contain a string that was identified as a dimension of Ovid, and then I can also see a bit of context of that mention. And similarly, I can expect the JSON, which is going to be just a list of all these references with unique identifiers that were assigned. Yeah. So in this case, well, here there is the JSON, and here I hope you can see all the identifiers, the CTS URLs that I've mentioned before. So it's showing some IDs for the reference, what type of reference it is, the label of the author that is cited, and also some context where the reference is found. Yeah, that was it.
Cool. I'm going to stop the YouTube broadcast for the purpose of the discussion, because there's no way this will be able to pick up everything anyone says anyway. So give me a second just to turn that off.